algorithm, namely maximum entropy and runoff forests. To evaluate the model performance, we consider widely used spatial predictive evaluation metrics and produce binary maps, response curves, and incent maps. A simple water balance equation was used to evaluate the climatic suitability for AWD in the potential irrigated rice area. We defined the climatic suitability for AWD using data on precipitation, evapotranspiration, and percolation. And AWD was considered suitable when there was a deficit water balance, which indicated the need for irrigation, and unsuitable otherwise. So the assessment was made for the 2 growing seasons on decadal stem cell. As a result, both massive and random forest model produced good performance with most of the metrics above 70% for the different thresholds used. The top 5 predictors of non-suitability for irrigated rice were extended sodium percentage, extended potassium, depth to groundwater table, Euclidean distance to stream networks, and precipitation of the warmest quarter. Here we compare the predicted and observed irrigated rice location for a few schemes, and we found a good matching between the current and predicted location of irrigated rice. We presented here the climatic suitability of AWD in irrigated lowlands for all the decades of the first growing season. And overall, 97% of the first growing season was found suitable for AWD. When this assessment was made for the second growing season, 57% of the season was found suitable for AWD. So in conclusion, we use environmental niche models to predict non-suitability for irrigated rice in Burkina Faso, and about 3 million hectares of lands were found potentially suitable for irrigated rice. The potentially suitable land were mostly located in North Sudanese and sub-Saharan zones. We evaluate the spatial and temporal mapping of AWD suitability on a decadal time span for a 2 growing season. And we found that AWD offers significant opportunity for reducing water inputs, both in the first and second growing season. Our study did not include socioeconomic parameters, such as water pricing, and we didn't also present here the result of the sensitivity analysis on soil percolation. Other studies considered the greenhouse gas mitigation potential associated with the adoption of AWD on national scale. We thank GIZ for supporting this work. Thank you.
Thank you, Elliot, for your presentation. I just saw in the questions and answers session that obviously there is a problem with the connection to this session. Now I think they found it on YouTube, so now it seems to work. So yeah, Elliot, thanks again for your contribution. There's no question on WUFA yet, but maybe one of the other speakers has a question here.
Maybe I can ask a question.
Yes,
Lawrence
please.
Bachmann. So he, in the presentation, he showed that there is a potential for 3 million hectares of irrigated rice in Burkina, which seems like really a lot to me, knowing Burkina quite well. But have you cross-checked that figure with what is the official national statistics on how many irrigated rice there is, according to Ministry of Agriculture, just to have a comparison of how much maybe is now already, irrigated?
Yeah, thanks. We actually compare this this with existing actually predicted areas, and while we found quite a large variation between the reports, there were reports on 300,000 hectares, others were on 1 million, others were on 3 million, 4 million. Actually, it depends on the approach that was used. What we observed was that the other approach actually focused on the land that could be irrigated through the river networks. But our approach actually went beyond and look at what are the potentially irrigated lands using the groundwater networks, and that actually offer opportunities to see to really map the potential for irrigable land in Burkina Faso. And we also validate actually our approach to see if our approach was able to predict the existing irrigating schemes in Burkina Faso, and we saw quite a good matching. So this presentation was quite easily previously shared with the national system that made some comment that we took into account, and we found that this figure that we've got is quite robust to inform on the potential irrigable land in Burkina Faso.
Okay, thank you very much, Elliot, for answering that question. Is there one more question here from the audience? Otherwise, I would suggest that we move on. We may have some time at the end of this session to discuss one or the other aspect, as we, in these talks, talk only about rice, basically, and some of the talks on rice production in West Africa. I think there will be some joint questions. And I'd like to ask Jean-Martial to now upload his talk. And Elliot, please, can you switch off your microphone now? Thanks for your talk again. And we will continue with alternative wetting and drying rice production in West Africa. A talk by Jean-Martial Johnson, who's at Bonn University. And there we go already. So again, questions can be raised first also on the Q&A session part on WUFA for all the contributors, the audience. And yeah, I'd like to ask Jean-Martial now to continue, and we're looking forward to your talk on potentials and risks of alternate wetting and drying in lowland rice production, dry savanna zone of West Africa. Stage is yours.
Thank you. Good afternoon, dear colleagues and professors. My name is Jean-Martial Johnson. I'm a PhD student at University of Bonn under the supervision of Professor Baker. I'm very pleased to share with you some key findings of my PhD research. I'm going to show you potentials and risks of alternate wetting and drying in lowland rice production in the dry savanna zone of West Africa. Rice is a strategic food security crop in sub-Saharan Africa. However, there is a large gap between demand and production in sub-Saharan Africa. Irrigated rice farming requires also more water than any other staple crop. Climate variability and water scarcity threaten food security and particularly rice production. And in developing countries and in arid and semi-arid zones, the adverse impact of climate variability and water scarcity are worse. This is the case in Burkina Faso, a Sahelian country. Alternative solutions were found to deal with water scarcity in irrigated lowland fields. For example, we have plastic mulching, aerobic rice, deficit irrigation, raised bed system, SRI, and AWD. The aims of these alternatives is to produce rice while consuming less water and maintaining high yield level. Among all those water-saving technologies, AWD is the most advocated one. To better understand what is AWD, it is worth to explain a bit how rice is traditionally produced in irrigated lowland fields. In irrigated lowland field, from vegetative phase up to ripening, rice is flooded. The inconvenience of this technology or these practices is that it consumes high quantity of water. But the main advantage is we have high and stable yields. In contrary, with AWD, field is flooded or are flooded at the vegetative phase around 15 days or 21 days after transplanting. And after that, the field is left drying out up to minus 15 or 30 centimeters. And when we reach this level, the field is reflooded again. So we have an intermittent irrigation. The main advantage of this technology is that we reduce water consumption without yield penalty. However, AWD is not a universal panacea for water scarcity. And in sub-Saharan Africa, this technology is largely unknown to smallholder farmers. Moreover, AWD could or may negatively affect rice yields. When we say AWD, this entails temporary aerobic. And this temporary aerobic soil could lead to low P availability, more terrestrial weeds, and low manganese, iron, and zinc availability. When we apply also AWD, we means that the field is reflooding, and reflooding entails nitrate losses by leaching or denitrification. So we would like to answer in our project research some questions. In this presentation, we will just answer 3 key questions. The first, what factors affect grain yield? The second, how much water is saved and at what price? And the third one, what is the effect of AWD on nitrate dynamics and nitrate losses? We carry out this study in 4 rice irrigation schemes, 2 in Sudanian zone and 2 in Sudano-Sahelian zone. We compare the 4 sites. We compare farmer practices, farmer water management practices with AWD technology. We assess soil moisture dynamic and irrigation water consumption. And we also assess nitrate dynamics in some fields during the dry season 2019. So finally, we compare 155 AWD and farmer practices plots, and we use mixed model. Concerning the first question, what factor affects grain yield? We found that the average yield is around 4.9 tons per hectare in all our 4 irrigation schemes. Grain yields are highly variable, both between and within sites. When we look at the season, we found that grain yields are higher in wet than in dry season. We also compare the yield according to the distance from the irrigation canal, and we found that the distance from irrigation canal had no effect on yield. With these general findings, now we would like to know how much water saving was saved and at what price. During dry season, AWD helped to save around 30% of irrigation water, and in wet season, 25%. Does this water saving impact yield? No, there is no apparent yield penalty with AWD. So AWD increased the water productivity by 64%. These findings are similar to the result showed or presented by Cario et al. In 2017 in a meta-analysis. In this meta-analysis, Professor Lindquist's team found that 23 AWD saved less than 23 irrigation water. And with this water saving, there is no yield penalty. Let us talk now about the third and last question. How does soil moisture relate to nitrate dynamics? On this figure, we can this figure shows that each AWD cycle gradually reduces soil moisture and concomitantly increase the nitrate concentration in the solution. When we look at the yield of the fields where we monitor and evaluate nitrate concentration, we found very high variability, around 38%. So we ask the question, can this variability explained by can explain the nitrate loss, or sorry, this nitrate loss, does this explain, or could it explain the high variability in yield? These losses, are they also related to nitrogen application rates? And are they related to the frequency and intensity of soil drying? When looking at the data, for the first question, we can say no. Nitrate losses are not related to nitrogen application rates. But we found that nitrate losses are related to frequency and intensity of soil drying. So in conclusion, we demonstrate that in the Sudanian and semi-arid zone of Burkina Faso, rice yield strongly vary between and within irrigation scheme and between seasons. AWD did not cause a yield penalty compared to farmer water management practices. AWD saved around 30% of irrigation water in dry season and 25% in wet season. However, AWD also increased soil nitrate losses by up to 30 kg per hectare. So we should be careful with AWD, as we show it can save water, but it may entail long-term trade-off in soil fertility. Effect on agronomic nitrogen use efficiency, weeds, and nutrient availability require further studies, and these studies are ongoing.
Okay, Jean-Marcel, thank you very much for your presentation. Can you still hear me?
Yeah.
Okay, very good. Thank you very much. I wasn't sure if there was a problem with the internet connection. Yeah, thanks very much for this very interesting talk. And I want to open the stage for questions. There's no question on the Q&A panel yet, but I have one question. You nicely highlighted the ongoing research on nitrogen use efficiency, which came to my mind when looking at these numbers. And I'm also curious if you consider the gaseous nitrogen losses, such as nitrous oxide, which is known to occur on higher levels and higher rates in drying re-wetting systems. Jean-Marcel, the question was if you also consider nitrous oxide emissions in the modeling approach, or if you also measure nitrous oxide emissions as a potential loss pathway of nitrogen.
Okay, thank you for this question. We did not measure nitrate oxide during this study, but we are planning to do, maybe not within my PhD research project, but maybe if we get another fund. Technically, this was not feasible in our condition.
Yeah, I understand. It's not an easy measurement, especially in the field. It's quite challenging. But yeah, you can also consider, or maybe a PhD after your PhD in the project, consider maybe also modeling that based on on some assumptions and some of the measurements you did. Yeah, thank you very much. Very interesting study. Is there any further question from the audience? There's no question raised in the Q&A panel yet. Is there a question from the other speakers?
I would have one question regarding a soil carbon. Did it also have an influence on soil carbon? Yeah, the humus content in the soil. And the second question would be about the type of fertilizers. Does it play a role? So for example, if you use organic fertilizers, would the losses be lower compared to when you use highly soluble mineral fertilizers?
Thank you for this question. Most farmers use urea as source of nitrogen fertilizer. We analyze carbon and nitrogen in those fields, but some data are missing, and this is why we do not present this data. Also, considering the short time of the presentation, we just provided key findings. But we do have soil samples, and these samples were analyzed.
Okay, Jean-Martial, thank you very much for the answer to this question. And we move on. And again, thank you very much for your very interesting talk. And we move on to the next presentation by Mr. Lorenz Bachmann about giving some insight into a GIZ project, if I understood it correctly from the abstract. And if you, Mr. Lorenz, Mr. Bachmann, can share your presentation on the screen, please. Yeah, that looks promising.
Can you see it now?
Yeah, now you just can, if you can switch on the presentation mode, beautiful. That looks very promising. Yeah, so the stage is yours. We stay in West Africa, I guess, in parts. So I'm looking forward to your presentation.
Okay, yes, thank you very much for this introduction. So we're moving a bit south now from Burkina down to Benin, to the northern part of Benin. And here on that picture, you can see some of the farmers that worked with us, but also some of the project staff. So our topic is reviving seed sharing for biodiversity conservation, food security, and groundwater recharge. Okay, let me try and explain a bit more what we did. I start first with an introduction into the study region. So you see it here on the left, it is this northern part of Benin. And this is a mountainous area with altitudes up to 1,000 meters. And some of the key challenges is what you can see here in this rainfall chart. If we look at the last 4 years where we conducted our work, you can see there's a huge variation in rainfall. For example, if you take 2018, this village Bukombe is below 800, while other communities are above 1,300 millimeters. And you should know the difference is sometimes only 45, 50 kilometers. Those 5 communities we worked in are very nearby. And if you then look across the years, yeah, for example, here in this Pegunyo, the rainfall varied from 1,000 to 1,400. So really a huge variation. And that makes it very difficult also to analyze the data we had. What did we actually do? So our idea was that we try to bring back old rice varieties and test them against new or modern varieties which come from research. And so overall, we had 137 tests of local rice varieties, and we had a total of 32 rice varieties of modern varieties. And this was in particular IRI varieties. IR 841 was the most commonly used reference variety. What was our methodology? So we started up with a collection of local rice varieties and description of these. And in that process, we could find 25 varieties. And then we established community seed gardens with those varieties. And we looked for farmers volunteering to test these. Then we based mainly our observations on farmer-led observations, so what they observed. The only thing the project actually did itself was to assist farmers during the harvest and take yield measurements. There was a research backup by an external consultant, which happened to be me in this process. And we did 2 farm visits in course of the production cycle to discuss the progress with farmers. And maybe another point of importance is the area estimates used by the farmers were based on their estimates. And we started off with very small areas in the first year and the second year, because farmers were still reluctant to apply to larger areas. And towards the end, the area sizes of the plants increased quite substantially, sometimes even up to 1 hectare. Now I come to the results. So we wanted to test the results in, because this is a water program, not an agricultural program. We were looking into the question, is it actually helping to improve water recharge, and come to a more economic use of water, and hopefully even an increase in groundwater tables. However, those measurements were only put in place last year and the data is not yet available, so I can't speak anything in that respect yet. I can only show you what is our working hypothesis here. So we were hoping that through coming up with afforestation, you can see a planting of trees near the actual rice paddies. Yeah, and you see this is 1 year later, so the trees are coming up. And by growing Chloricidia on the farm bunds, that we could serve two purposes, that we have organic manure and that we have a better water retention. And I show this again with this next small model on water recharge. So you see in the north of Benin, most of the watersheds, they actually don't use farm bunds. They are just cultivating the rice in the watershed without any bunds. So one recommendation was to create water bunds, to have a better infiltration. And this again with our hypotheses to increase water infiltration. Then the second step, doing the same thing, is to have the afforestation on the river banks. Yeah, and the idea was also to use the trees of these leguminous trees, the leaves, to fertilize the rice paddies. In addition, Chloricidia was also used on the farm bunds with the same purpose, increasing available green manure. And our hope was also that the tree roots could help to reduce nutrient losses and the leaves recycle these nutrients back to the crops, also leading to a better yield. So that's about, I would say, the theoretical concept behind improving water recharge. However, the results are not yet there, but that's the concept. And the concept was actually approved by farmers who thought, yes, it could be working, but we are still a bit early in that respect. And now I come to the agronomic results regarding the seed sharing. And here you can see that basically what we did is sharing those seeds with many farmers and then testing them and talking about the yields. So we first asked for the perception of yield differences between local rice and modern high-yielding varieties by farmers. And we just asked them, based on their observation and what they have harvested, how do you rate the success? And here the surprising result was that the local varieties were seen as performing better, thus having higher yields in 52% of the cases. Yields were rated as equal in 22%, inferior just by 20%, and especially in the first year in 2016, a quite huge number of farmers felt the areas are just too small to make any meaningful evaluation. Yeah, but this shows very clearly that the local varieties were perceived as doing, on average, yeah, you could say almost 70% of the cases equal or even better. We also measured the yields exactly, and here you can see the average for local rice varieties was 2.3 tons, whereas the average for high-yielding rice was just 1.9 tons. And it should be clearly said that all these trials are actually relating to rain-fed rice. So we're not talking about irrigated rice, but it was all rain-fed rice. And interesting, I think, is to know that some of the local varieties, like this Gambiaca, for example, also had very high yields, but usually this only in combination with high rainfall or availability of a lot of water. Then we also had varieties which are local varieties which are very, very efficient in water consumption. However, here the yields were a bit lower. But we also had very interesting varieties which became very popular, like this Capancho Blanc Cycle Court, which is quite high yield, also almost 2.5 tons. And this one has a cycle of only 100 days. So this one was found to be interesting, especially in the cases where farmers faced a shortening of the rainy season. Yeah, another key learning we had in combination of this seed exercise is that we actually asked ourselves, where are farmers actually growing their rice varieties? Yeah, and this, what you can see here, is kind of a theoretical cross-cutting view through a watershed, which are very common in the north of Benin. And here's just a picture to illustrate that. Yeah. And you can see, for example, that this zone 7, which is rather dry, that is what you would find on the upper banks of the watershed. Then if you have the zone 5, that would be water between 0 and 20 centimeters of flooding height as a maximum during the rainy season. That's where you would see the people now standing here. Or if you go for very, very high water levels of up to 1.6 meters, you could see that here in the middle of the valley, very, very near to the actual river and water flow. And that means the water height is very variable, and also the suitability for growing is, of course, very variable. And we could find out that most of the varieties, especially the modern one, are just grown in the zone, what we call 4 to 5, which is up to a maximum of 0.5 meter of flooding. Yeah, and our local varieties had the advantage that some of them could even grow into the zone 3 and 2, and thereby expanding actually the area which can be used for growing rice. And I think this is a major advantage of this focus on many varieties, because like that, farmers can cultivate more land. And also the upland drought-resistant varieties, which can grow in this upper part here, where there is less water, really give farmers a bigger choice of what they can grow in different areas of their watershed. And important is also, as I mentioned in the first slide, that due to that huge difference in annual rainfall, these levels of maximum water flows are quite variable across the years. So that means maybe in one year, the maximum water flow reaches up here, but in other years, it's only reaching up to here, if I show it on the photo. So that means the areas which are available for cultivation are changing all the time, and they are not predictable at the beginning of the rainy season. And that really calls for growing a diversity of different varieties. So what have been our conclusions on this seed exchange in particular? So we said seed exchange fairs combined with farmer-led trials are a good means to demonstrate the benefits of a diversified rice production strategy. And the strategy for us is, which we recommended, don't just grow one variety, but rather grow 2, 3, or 4 according to the different lands you have. And it could be shown that farmers grow that follow this strategy, they have several different benefits. First of all, there is a reduced production risk and better yields, as we saw, up to 20% higher yields. And over several years, this also reduced the risks, and the economic returns is better, because we advised farmers at the same time to stop using chemical fertilizer to avoid costs. Now, doing this is anyway a practice in the north of Benin for many farmers, because in many years fertilizer is not even available. So that means they only use fertilizers, if at all, if it's available, and only on those lands where they can control the water height. But this actually is rather a limited area where that is possible. Also, we said larger areas can be planted with rice due to the better adaptation to the terrain. And we could see more flexible crop duration brings better adaptation to the variable length of the rainy season. So the variation in terms of growing period in the different varieties we could find were between 90 days to 200 days. So really that gave farmers a much better choice to decide which varieties they could plant. Of course, it also brings an advantage in terms of taste. More varieties have different tastes, and they are also, some of them are healthier because they are more nutritious than other varieties. And an important finding we could see is that the recognition to the benefits of traditional varieties strengthens the self-esteem of remote local communities. And also that recognition of old rice varieties helps to increase the market prices for those varieties. And I think it's maybe quite interesting to share, because when we started to do this exercise 4 years ago, a lot of people ask us, but why do you do that? That old varieties, they're not any good and they're not performing. And why do you think people should be doing that? And at the end, we found out actually the opposite is true. The local varieties are doing better than the modern ones. And like that of course increased a lot the self-esteem of those farmers who had always continued with their old varieties and which were not listening or only partly and trying out what new varieties are offered by research. Okay, so those are the findings. So we also have some literature to support this. And I would like now to thank all of you for listening to this short talk. And of course, I would also like to thank to all the farmers that participated in this exercise and helped to make this research possible. Thank you.
Yeah, thank you, Mr. Bachmann, for the insights into this very interesting project with some aspects of agroforestry and yeah, social, economic, and ecological aspects, so in the true sense of sustainability. We have time for questions as there's one talk less in this session. So are there questions from the audience? There's no questions in the Q&A session yet. Any question from the other speakers? Not yet. I have surely one question. As you said, the water levels are in a way unpredictable and can vary. Did you also consider using variety mixtures instead of the pure old varieties? You showed nicely that some of them are more drought adapted and others grow better when there's higher water availability. And if you run secure and not knowing how much water you will have available, isn't it a strategy to kind of reduce the risk by having a mixture of these old rice varieties?
Yeah, I think that definitely would be also a mixture. However, then you have the difficulty that they may not be ripening all at the same time. And therefore, what farmers usually prefer is to have smaller plots and then put that variety in this plot, put the other one in the next plot. And like that, it's also for them easier to steer it. It also has to do, of course, with the consumer preferences, because they're all different in taste. And if you mix them all up, that makes it more difficult to actually sell the rice.
Okay, thank you very much. Any question from the audience by now? Matthias Becker raised his hand. I just saw now. Sorry, Matthias, you are hiding somehow. So what's your question?
Thanks, Florian. Lawrence, I think we're working in very similar environments. We are looking at floodplains in Tanzania or in Eastern Africa in general. So again, hydrologically highly variable environments where I just confirm the traditional genotypes are by far out-yielding the modern ones because of the hydrological risk. Depends on the years necessarily. But I'm just surprised in Eastern Africa, in these highly variable environments, there's a clear predominance of traditional genotypes. Farmers are not interested in modern ones. You seem to say that they are more in contact with modern genotypes and you have to rather push them to use the traditional ones. What do you think is the reason for that?
Yeah, we were actually also surprised. So for example, and I think it clearly has to do with the impact of extension work that really heavily advocated the modern varieties. So for example, we tried to introduce the same concepts in the south of Benin 2 years ago. And there we were shocked because we tried to follow the same approach. We tried to find out first how many old varieties do still exist in those areas. And we couldn't find any. So we could only find modern rice varieties. Whereas in the north, where the variability is still much higher, where there's mountains, where there are more remote communities, where inputs are not so easily to be obtained, there we still found that roughly 25 different varieties. Yeah. So clearly in those areas, the farmers also understood that they are important and they did it by themselves. Yeah, but they were also trying modern varieties, especially on those fields where they can control or where water flow is less, I would say, variable, and where modern inputs are less lost, because on many of the other watersheds, if you would apply fertilizer, it would just be lost with the next flood coming. So it's just not interesting going for that approach.
But one of the risks of these traditional genotypes, you mentioned Gambiaca. I mean, Gambiaca is a 145-day variety. It means you need a much longer time in the field, and that increases again risks probably to sudden droughts. So maybe what if you give a safe guess with climate change, with rainfall variability increasing in the area of Western Africa, do you still think that these traditional varieties, despite their well adaptation to variable hydrologies, will in the long run still play a role? Because just to mention it again, we see in Eastern Africa that with the shortening of the growing season, the traditionals cannot mature anymore when water becomes a limiting factor or when the rainy season starts just too late. Give me a safe guess about your estimates.
Yeah, it's the same in our case. So the most popular varieties which many farmers picked was at Capancho Blanc Cycle Court, which is the shorter varieties of 3 to 4 months. Yeah. And they picked it as on purpose because they said, yes, in some years the rains come so late that we can't sow Gambiaca. Yeah, so we have to go for something else. That means the farmers are really happy if they have several different varieties and they can decide, depending on the onset of the rainy season, which varieties have the best chances to succeed in that year. Yeah. And therefore, we really strongly advocate for just more diversity, including the old varieties, because that just gives farmers better choices. And that's also my experience, which I gained a lot from a network in the Philippines, where farmers have also moved to having at least 4 to 6 different varieties each year. And depending on how the rainy seasons are developing, depending on the land which they have, whether it's irrigatable or not, whether they have some proportions with more upland or lowland, they can then really decide what to put where.
All right, Mr. Bachmann, thank you very much for your presentation, for your insights. Matthias, thanks for your contribution in the discussion. I think we could go on with that. There are many questions left, of course, and that's what it's about. Yeah, you, Mr. Bachmann, mentioned the next keyword already, the Philippines, and we leave Africa now and move on to Asia with Ms. Wehmeyer from the Philippines, from Iri, if I got it right. We'll talk about some sustainable farming practices in Myanmar, where we find strongly transitioning agricultural sector. And I see the presentation is uploaded already. So Ms. Wehmeyer, the stage is yours. You've got 10 minutes and then we have time for discussion. Thank you.
Thank you very much. Good afternoon to everybody. My name is Helena Wehmeyer, and I'm a research assistant at the International Rice Research Institute in the Philippines and a PhD candidate at the University of Basel in Switzerland. My presentation today is about introducing sustainable farming practices in rice production to Myanmar's traditional transitioning agriculture sector. First, I would like to give an introduction on Myanmar's agricultural sector regarding rice production, and then I will quickly talk about the Corrigap project. I will present my research objectives, how we collected our data, our results, and the conclusions. First, I would like to present some information on the historical development of Myanmar's rice sector. So Myanmar used to be one of the largest rice producers in the world, especially in the 19th century, which was made possible due to British rule. Rice was and has always been Myanmar's dietary staple food, but especially during the second half of the 19th century, it became its main export commodity. This was due to the fact that British capital and policies actually fostered the growth of Myanmar's rice sector, which then led to Myanmar becoming the world's largest exporter of rice. This was actually done by strong expansion of arable land in order to continue the process of growth. In this regard, rice production was highly weather dependent and water was the main scarce resource because not much technological development was actually fostered by the British rulers. Hence, after World War I, and with the start of the Great Economic Depression in the 1930s, expansion started stalling in Myanmar, and production, and especially export, did not grow as strongly as in the decades before. This was due to technical innovation remaining low because it was not regarded as necessary. This was followed by the military regime that started in the 1960s, and this hardened the existing structures and actually led to a collapse of the exports from the 1960s on. Nationalist policies restricted the access of rice farmers to innovations, especially during the time of the Green Revolution. And furthermore, they actually introduced price controls, which limited farmers in their rice production in general. So this led to Myanmar's rice sector actually being minimal regarding exports and low production regarding national quantities. So this has led to Myanmar struggling today with several factors, and their agricultural challenges are especially due to low level of technology. So this means that farmers still heavily use manual labor, that they don't have much mechanization, and they continue with traditional farming practices. This actually leads to low productivity levels and low profitability for rice farmers. As I said, it's labor intensive and they use very little input, especially compared to other countries. In this case, if we look at neighboring countries such as Vietnam or neighboring countries in the same Southeast Asian region such as Thailand, Vietnam, as well as Cambodia and Laos, these countries are seeing a strong increase and fast development of their rice sector, which in Myanmar has not yet been perceived that strongly. Furthermore, the political situation of Myanmar is delicate, and farmers remain especially vulnerable to internal as well as external policy restrictions. Thus, these limitations actually delay the development of Myanmar's agricultural rice sector further. Therefore, the Kori Gap project started in 2012 in Myanmar, as well as in 5 other countries in Southeast Asia. Kori Gap stands for Closing Rice Yield Gaps in Asia with Reduced Environmental Footprint, and its objective is to reduce rice yield gaps in 6 major irrigated rice canneries in Southeast Asia. So in Myanmar, the project started in 2012, and the objective was to find out about the level of yield gaps and their contribution to food security. Farmers were interviewed and a needs assessment was conducted. In the second phase of the project, in 2017, after the introduction of best management practices, which should be adopted by farmers, a second evaluation was made. Therefore, I will now come to my research objectives, which are to investigate the development of yield output and agricultural profitability after the introduction of best management practices. So in my study, what I did was to examine the development of farmers from 2012 to 2017 to evaluate factors influencing the farmers' productivity among adopters and non-adopters, and analyze the influence of social and environmental factors in farmers' agricultural performance. Our study area was in Bago region, in the Irrawaddy Delta in Myanmar, and we were in one township, namely in Dai U township. There we collected data from 200 farmers. We interviewed them using a household survey questionnaire. In 2012, at the beginning of the Corriga project, a paper-based survey questionnaire was used. By 2017, after the introduction of best management practices, we were able to use a tablet-based survey using the Compare application. We collected data, socioeconomic data, socio-demographic data, agronomic data for the cropping seasons of 2011 to 2012 and for the cropping seasons of 2016 and 2017 in 8 villages. The farmers were categorized into an adoption group and a non-adoption group, which means that the adoption group actually said that they adopted the best management practices which had been introduced between the years of 2012 and 2016. For the final data analysis, we selected 160 farmers. First, I would like to give a quick overview about the farmers' characteristics. So most of our farmers were male, about 14% were female. Most farmers were around 50 years old by the second survey in 2017, and they had been farming for almost 30 years. The average years of education was 6.9, so almost 7 years. The farmers were either rice farmers or rice pulse farmers. This had changed a little bit in 2017, where more rice pulse farmers were present. The farmer groups were clearly divided. There were approximately 50% adopters, 50% non-adopters, and regarding the crop establishment method, most farmers were transplanting in the first phase of the project, but a significant amount had actually changed to direct seeding by 2017. So our agronomic results showed that the cultivation area of the farmers did not change significantly. However, the yield, the non-rice income, the amount of credit that farmers received, and the annual income all increased significantly over the course of 5 years. This was also the case for labor, input costs, and rice income. So here we see that during the beginning of the transitional phase of Myanmar's development, all farmers have actually seen a significant increase in their agricultural situation. Next, in our yield analysis, we conducted a multiple regression analysis in which we included all of the socio-demographic, socioeconomic, and agronomic variables. And what we found was, for our 2012 model, was that multiple factors, especially socio-demographic factors, were relevant and significant for the yield. However, by 2017, only the cropping pattern remained as a significant factor for yield prediction. This could be explained by the fact that farmers actually switched from one group to another. Therefore, farmer group or adopter, non-adopter was not as important anymore. And several farmers actually changed their cropping pattern from rice to rice pulse, which could have been an important element for seeing beneficial yield increases. Finally, we conclude that all farmers, no matter the group, saw a positive agricultural development from 2012 to 2017. Yet there were no differences between adopters and non-adopters. This could be probably due to the fact that many farmers switched, there was a spillover effect, and most probably farmers adopted certain elements and did not adopt other elements. We saw that the cropping pattern was the most significant element for farmers' yield increases between 2012 and 2017. And finally, we did not see a strong influence of social and environmental factors on farmers' agricultural performance. So I have to finally add that there were some limitations to this study. First of all, we actually planned on doing a third round of interviews during the summertime, which, because of the current situation, couldn't take place. We also have a small sample size and are limited in our geographical area. Thank you very much, and please let me know if you have some questions.
Yeah, thank you, Helena, for the interesting talk with quite some interesting insight also on the socioeconomic side of rice production. Yeah, I open the stage for questions. I learned that the Q&A at the WUFA platform still does not properly work. It occasionally gives some questions, but we seem to have some issues there, which means we rely on questions from the Zoom attending audience. So maybe there's one or the other question from you. Matthias, yeah, I saw your hand rising. Sorry, it's very small on my screen.
Thank you, Florian. Helena, thank you very much. I like these diachronic studies where you look at before and after, because you can really trace changes. I'm just wondering, 5 years is a relatively short time for such a study, because the main changes occurred a bit before 2012. Actually, they started around 2000 when we had the real traditional systems with water buffaloes. What made you choose a 5-year interval only for a diachronic study?
Thank you very much for your question. So in that case, the two surveys were conducted based on the Corriga project's phases. So the first phase, at the beginning, Myanmar was one of the main countries. So that's why the first survey questionnaire was conducted in 2012. And the second phase only started in 2017. Compared to the other countries such as Vietnam, Sri Lanka, and Thailand, there is a larger time difference, because in Myanmar, the household questionnaire was conducted much earlier. In the other countries, it started in 2014 and 15. I was back then not part of the project. And I have to add that although 5 years has passed, the original objective was to do a third questionnaire, survey questionnaire, to make sure that we have 3 different data points. Furthermore, over the time of 5 years, there were several smaller studies conducted on how farmers were adopting the best management practices, and feedback was actually collected from them through interviews and learning alliance focus group discussions.
Okay, I think we should link up, because we did one such study in Myanmar where we asked actually, what did you do 20 years ago? What did you do 10 years ago? And what you're doing now? So it was only one questionnaire survey, but we had at least 1,200 farmers. So maybe we can link up and see if we can jointly continue to work in this area. One of the things that struck me was your high rate of direct seeders. Is this direct seeding of rice? Because in our observation, wet season rice is never dry seeded, not in the Delta at least, because of the high risk of submergence, so they are all going for transplanting. Or is it a very specific site where you have been focusing on?
So this is so thank you very much. I very much appreciate your idea of working together. Regarding your question about direct seeding, to put it into perspective, we asked farmers in general if they did direct seeding, no matter in which category, in which season, if it was the wet season or the dry season. And this is how they were separated per group. Generally, there were some incentives for farmers to try out direct seeding in order to have a less laborious activity, and with the varieties that were introduced to the farmers, this was actually also seen as a beneficial way for the crop establishment.
Sure. Okay. You need labor and you need the herbicide, otherwise you cannot do direct seeding.
Yes.
We found a lot of direct seeding, a shift towards direct seeding in the central dry zone of Myanmar, but very little actually in the delta. So I'm very much interested in your study site. Let's link up after the Tropentag.
Thank you very much.
So that's a fantastic result already. So the next project is on the way, so to say. Thanks for the question, Matthias. And maybe one question related to the last question to you, Helena. I think in your abstract, you mentioned that input availability and input prices are quite crucial. Can you elaborate on that, especially in terms of the nutrient inputs? So did that change over time, the availability and the prices of nutrient?
Yes, so they changed due to several aspects. First of all, from a macroeconomic aspect, the fact that farmers received better access to inputs was important. Compared to other countries in Southeast Asia, inputs or input use, especially fertilizer and pesticides, is still remaining low. And the objective of Corrigap was also to make sure that the farmers in Myanmar do not reproduce similar or the same mistakes as we can see, for example, in China or in Vietnam, where input use has become, or overuse of inputs has become a major issue. So in Myanmar, there's still the possibility to make sure that farmers have a better access to inputs without trying to overuse inputs in order to have fast yield increases and actually go against the idea that more is more.
All right. Thank you very much, Helena. I think we open the discussion now to, let's say, discussing all the talks we heard today. As I said, one of the talks was canceled, so we still have some 10 minutes, 15 minutes or so for discussion. Yeah, so again, the stage is mainly yours, the people here able to join the Zoom. There is still a problem, I think, with the Q&A. At least there are no questions coming up. So I think Mr. Bachmann, you had a question, right? And then back to Mr. Becker again.
Yeah. Okay. It's again maybe a question or a suggestion of collaboration. I happened to work in Myanmar also last year, and we were actually following in that project a completely different approach. We were saying less input is better. And we were saying different varieties is better than modern varieties. So similar to what I suggested in Burkina Faso, in Benin. And our finding actually over there was that farmers which kind of are allowed to practice that, to go into diversity, they had the biggest advantages, whereas those farmers which were forced into the regime, and this is now really my question, because in the Delta we had many reports from farmers that were saying actually they are not even allowed to go out of rice production, but they have to grow rice even 2 or preferably some even wanted to have them doing that 3 seasons a year, 3 cycles. And that completely exhausts the soil, and that also forces them, for example, to sell out their cattle, and because they have no more pasture land for cattle, and this leads actually to a big loss in income from livestock. So our thinking was actually it's the opposite that is true. If you would be allowed to stay diverse, then your incomes are likely to go better, because in our survey we found out that especially for 2019 incomes dropped tremendously due to the fact that the prices are going down in Myanmar due to maybe overproduction or difficulties to get the rice sold. So that's why we thought it's better to stay diverse. I don't know what the IRRI strategy is for Southeast Asia.
So the strategy of Corrigap is to foster sustainable development and reduce yield gaps. So the idea is to make sure that an appropriate amount of input can be used, and especially regarding Myanmar's situation is to give farmers access to inputs. So we're talking from one perspective, of course, classical inputs such as fertilizers and pesticides, but in that case, we also mean irrigation technology, mechanization, and so forth, which are elements that so far in the regions where we are not that present as strongly. It has improved significantly, but as far as we see it, there's still a longer way to go. The idea with Corrigap is to avoid the problems that we see in China, in Vietnam, in Thailand, and so forth, where certain elements have been introduced too fast. Farmers are not correctly trained on how to use certain modern technologies. So the idea in Myanmar is to not necessarily have fewer inputs, but to make sure that there is a sustainable level of both in order to achieve higher profitability levels for farmers. And on the other hand, also to make sure that there is an ecological and environmental aspect that is not overusing natural resources.
Thank you very much, Elena, for your contribution here. I think that's a discussion I pretty much like, that it's in the end also the question, how can we actually communicate our findings, our research? And sometimes my question is, do we need further research, or do we need more communication of the knowledge and finding ways to communicate this existing knowledge? And that's why I like this Tropentag very much, because we bridge the different fields of expertise and the different projects and different areas from West Africa to Asia and back and whatever. But there was one further question by Matthias.
Yes, thanks. When you listen at the first presentations by Elliot, by Jean-Martial, to a certain extent also by Lawrence, it's about water. It's about trying to save the resource water or adapt genotypes to hydrological situations. Now, in Myanmar, it was a different issue. It was inputs. What is the reason? What do you reckon? And I'm not asking only Helena, I'm asking everybody, where is water saving a priority? It's not only because it's drier zones, because the same is true for the central dry zone in Myanmar. It's not only the agroecological zone. Where is this prioritization of water-saving rice production coming from, and where is it likely to pay off? What are the niche environments? And on the other hand, Elena, maybe to you, where do you think are the niche environments for higher inputs? Because again, central dry zone, they are using 60, 80, 120 kgN per hectare, so you don't want to go for higher N inputs there. So how can we move on to this very different, very diverse strategies? On the one hand, water saving, adaptation to hydrology, or on the other hand, yet increasing inputs. How can we move ahead and try to identify the niches where which approach is likely to pay off best?
Maybe I can also add my question or comment to that to further contribute to the discussion. I mean, it's also about income opportunities, and I found this model and concept, this agroforestry model and concept in Benin quite interesting, where of course from a scientific point of view, have a lot of questions how nutrients and water are efficiently used. But Mr. Bachmann, in your project, the perennials you consider, are they just aiming at contributing to profitability of rice, or are they also providing another income source for farmers in, let's say, the traditional true sense of agroforestry, creating multiple income possibilities? Or is it aiming at improving rice production mainly?
Well, actually, we were just focusing on rice, but we did the same agroforestry approach also for the rain-fed areas. Yes, that means for other crops. We looked into millet and also into sorghum. But the main focus of this project was on water. So that's why finally we decided to work a bit more on rice. But yeah, of course, you could apply to also to other crops, and that's what I think is the best approach, yeah, to really go for diversity, which means also diversity of crops, not only rice but more other crops as well. I think in Myanmar, if I go back to the question, was what Mr. Becker said, why are they not looking into water saving? In the Delta, farmers where I worked have some 3,000 to 4,000 millimeters of rain. They rather have a problem with water flooding, not water scarcity. So really, depending on where you are, the problems are different. So I think Myanmar and Burkina or West Africa, very difficult to compare. In terms of water, at least.
Completely agree. I mean, Arakan coast has even 7,000 millimeters. So
yeah.
Water saving is not an issue there. However, it is when you move to the central dry zones.
Yeah, there again, that's the northern part of Myanmar. Then it changes.
Maybe just to add on Florian's question, you mentioned Gliricidia as one of your prototype species. I mean, Gliricidia has been researched by Kang et al. At IITA in the 70s, has been picked up by Africa Rice in the 90s, has been worked on by, is still being worked on by ICRAF since the 2000s or so. But I think we all these groups having worked on this alley cropping or let's call it legume integration in these systems, that what we need are multi-purpose legumes. It's not a pure green manure legume that's going to do the job. It has never been adopted since we do green manure research, not at large scale at least. And I think when we look at multi-purpose species, and maybe that's a recommendation rather than consider for future activities, maybe to replace the Gliricidia by something that provides direct income. I think that's the outcome of many of the economic analysis coming out of IITA, of ICRAF and of others the last couple of years.
Yeah, thank you very much, Matthias. That was more or less also the direction I wanted to lead the discussion to, that if we want to have solutions for the farmers, it's not about only considering rice or considering soil, as I'm a soil scientist, but also connecting that to, let's say, the overall goal, which sometimes is probably more challenging. And I found this concept, well, I would say for the subtropical research, old concept of agroforestry in Germany, it's now becoming a bit more popular. So the German agriculture can actually learn a lot from tropical, subtropical agriculture in this regard. But considering, let's say, the multi-purpose use of the system, I think is something we should more elaborate on in this context. So, but this session was mainly on rice, or only on rice. And I highly appreciated your contributions. We have surely some time for one or two more questions. And again, I don't know exactly if this Q&A thing works right now. As far as I heard, it doesn't.
I got a message on my portable phone that the Q&A is down for technical reasons.
Yeah, that's what I heard too. I thought it works again because I was trying to send out a test and the test showed up. But anyway, we don't want to bother about the technical things. I think we had a nice, vivid discussion here, which we definitely need to continue then on the next Tropentag, the latest. And I think there are some connections already brought up here, which is very nice and a very positive outcome of every Tropentag, that people meet and that we can allow and facilitate this also online is, I think, already a very nice outcome here. So thank you very much, all of you, for your contributions in talks and discussion, in questions and answers. And I would like to highlight that we have two more sessions coming up tomorrow, two poster sessions on assessing farming systems at different scales. One is tomorrow morning at 8:30, and another one is tomorrow evening at 5 o'clock. And this is an even broader range of topics we're going to deal with in the poster sessions. And I'm looking forward to meeting one or the other of you there as well. So thanks again, and hope to see you in person at some stage or online in one of the next sessions. Have a nice evening. Bye-bye.
Thank you.